Hello, everyone. My name is Yufeng. I am a PhD student from University of Southern California. Today, I'm going to present our WACV's work, which is FGNet, Facial Action Unit Detection with Generalizable Pyramidal Features. This is a joint work with ByteDance. So let's first start with the background. The facial action coding systems, or FACS, is a taxonomy of facial activities that can describe expressions through action units. So for example, inner brow raiser, AO1, and lip corner puller, AO12. Unlike facial expression of emotions, FACS can provide an objective measure tied to the exact movements of facial muscles to describe specific facial behaviors. And a certain combined movements of these facial muscles pertain to a displayed emotion. So for example, happiness is calculated from the combination of AO6 and AO12. So action unit detection is a task to detect if the action units on the face are active or not. So there are several challenges. So first is manual annotations of action units are cumbersome and costly. And common action unit datasets, for example, BP40 and DSPA, contain only a limited number of subjects. Usually, there are less than 50 subjects. And this will lead to the poor generalization ability for the deep learning methods. Well, as for existing methods for facial action unit detection, these methods are usually evaluated with within domain cross-validation, so which means they are trained and tested from the same dataset. While the generalization ability to the other datasets, so for example, model is trained and tested on different datasets, has not been widely investigated. So in fact, promising within domain performance can be due to overfitting, and therefore cross-corpus performance can suffer a considerable loss. So as you can see in the figures on the right, there is a huge performance gap between the within domain and the cross-domain action unit detection. While on the other side, in the field of the semantic segmentation, recent studies show that the intermediate features of generated models like GAN or diffusion models are well suited for the pixel-wide segmentation tasks and exhibit out-of-domain generalization ability. And therefore, inspired by the success of the GAN features in semantic segmentation, in this work, we propose FGNet, which is a facial action unit detection method that can better generalize across different domains. So here we show the overall architecture of our proposed method. So the general idea of FGNet is to extract the generalizable and the semantic rich deep representations from a well-trained generative model. So FGNet will first encode and decode the input image with a StyleGAN2 encoder and a StyleGAN2 generator, which is trained on the FFHQ dataset. And then FGNet extract feature maps from the generator during decoding. In order to take the advantage of the informative pixel-wise representations from the generator, FGNet detects the action units through the heat map regression. And we propose a pyramid CNN interpreter, which incorporates the multi-resolution feature maps in a hierarchical manner. And the proposed module makes the training efficient and captures essential information from nearby regions. And thanks to the powerful features from the generated model, pre-trained on a large and diverse facial image dataset, the proposed FGNet obtains a strong generalization ability and data efficiency for action unit detection. So as for the experiments, we select two widely used datasets for action unit detection, namely DSPA and the BP40. And these datasets are captured from different subjects with different backgrounds as well as lighting conditions. So we perform two different settings. First one is within domain evaluation on BP40 and the DSPA. So we follow exactly the same evaluation protocols as the previous studies. So both datasets are evaluated with subject-independent three-fold cross-validation. So specifically, we use 2 folds for training and 1 fold for validation, and we iterate 3 times. And we also perform cross-domain evaluation, so which means we train on one dataset and test on another. In particular, we perform two directions. They are BB40 to DSPA and DSPA to BB40. So for each direction, we use two folds and the one fold of data from the source domain as the training and validation set, and we use the target data as the testing set. So here we show the experimental results. So the proposed FGNet method has a strong generalization ability and achieves state-of-the-art cross-domain performance. On the other hand, FGNet also achieves comparable or superior within domain performance to the existing method. In addition, we also perform data efficiency evaluation. So specifically, we train the model with 100, 1,000, 5,000, 10,000, and the whole data set for the training and evaluate the model's performance. So we can see that FGNet is a data efficient approach, and with only 1,000 training samples, it can achieve decent performance. So in summary, in this work, we propose FGNet for generalizable facial action unit detection. FGNet extracts StyleGAN2 features and uses a pyramid CNN interpreter for action unit detection. Compared with the state-of-the-art, the proposed method achieves superior cross-domain performance while maintaining competitive within-domain performance. And in addition, FGNet is data efficient and achieves competitive performance even when trained on 1,000 samples. And at last, our code is released at the GitHub. And if you are interested in our work, please come to our poster session. Thank you.